Let's do a wide open throttle launch, shall we?
Let's do it.
Let's do it. Just instant to the moon. They sound really cool. The little that's awesome. Hello, good morning and welcome to one of the best days at work ever. You join me here with Magna at Hollyoaks Off-Road Park, where we're going to be exploring basically a high-level overview of all of the technology that Magna offers. So we're going to be off-roading with some of their electric powertrains. We're going to be, after we're done off-roading and doing stupid stuff with a lot of their cars, we are going to go over to a tech center where we're going to display some really cool technology, night vision, alcohol detection. Consider this a really high-level overview of some of the newest Magna technologies, all in one video. And then of course, plenty more to come. We love working with Magna. They're one of our favorite supporters here at Out of Spec. We've done so much with them. And one of the cool things is every time I drive a Magna vehicle, I always give it back with no tires. And somehow they're happy about that. So we're gonna go tear up a fully electric Jeep Gladiator that they've converted out on the trails, talk about electric motor design, powertrain distribution, calibration of these things, all the stuff that you and I love to nerd out about. And then there's just going to be so much more tech all in this one video. So let's hit the trail here at Hollyoaks Off-Road Park. A huge thanks to Magna for sponsoring this video and having us out to Michigan to share all of the cool stuff. All right, guys, we are in for a super fun day today, basically going through a high-level technical demonstration of a lot of Magna's technology. It would be impossible to put everything in one video because, as I always say, Magna's the biggest company that no one's ever heard of. They've been a huge supporter of Out of Spec, but again, I only really work with companies that I'm fully believe in and that I totally, absolutely love to share, and Magna's one of them. So what we're going to do is take you, again, through a bunch of technology, starting at the top with powertrain. And there's been some huge trends in the auto industry. I don't need to explain it to you, where we're all shifting to electrification. I mean, almost something like 70 or 80% of Magna's engineering effort is full battery electric powertrains. And they have a ton of engineers. That's so many people. And, you know, you might be wondering, where do these powertrains end up? Well, Magna, of course, doesn't make a Magna car, if you will. They're a supplier in a sense where, you know, a company like Stellantis may choose to award Magna the contract to power some of their vehicles with electric motors, or GM or Ford. It really doesn't matter. For example, we know that the front motor in the Volkswagen ID.4, the MEB platform, is a Magna electric motor, that induction motor up front. But today we're talking pickup trucks. So we have two vehicles to showcase with you. We have a GMC Sierra 2500. That's the combustion one. There's a fully, they also do the transfer case in that truck. I've done a video on that too. But they have a fully electric swapped one of those, which is one of the first electric applications to have basically an electric motor on a solid axle. They call it the eBeam. And it means that the electric motor and the housing take the forces of the truck. It's an unsprung piece of material, which means that it's actually moving and taking the bumps along with the rear wheels. And it's designed that way to take the stresses of towing and hauling mostly, but also for some off-road applications and heavy duty use. So we're going to drive that first. We've driven that vehicle together. So just a quick course on the off-road. They've added a couple functionalities since the last time we've driven that. Again, there's a dual motor permanent magnet system in that vehicle. They now have an electronic front end motor disconnect. They had it before, but now it's automatic. So a bit like if you drive a Hyundai Ioniq 5 or EV6 and you're cruising along and you floor it, it's got a rev match for the front motor, connect the clutch, and then re-accelerate, and you can feel that process. Magna tells me that that happens so much faster, so much smoother than almost anything on the market, and we're talking big, juicy electric motor up front. The next thing we're going to drive quickly is the Jeep Gladiator, and again, it's their own powertrain that they've put in it, but that's a dual permanent magnet system. I'll show you the motors here in a second, and they're both on solid axles, so it's the first time I've seen a solid e-beam axle essentially with an electric motor that allows for steering, which is sort of the next generation. Better powertrain control strategy, really next level, sort of low speed application here for rock crawling and getting that perfect, you know, no motor cogging type situation on these big uphills and downhills. We'll talk to some of the engineers about that. But we're starting with the most fun, which is ripping some vehicles off-road. So Ryan's behind the camera, he's joining me. Ryan, you ready to do some Magna stuff?
Very excited.
Can't wait. So let's jump in the EtelligentForce Pickup truck, a known vehicle that we've been in before. It has a prototype 83 kilowatt hour battery, two permanent magnet electric motors, making 500 and something horsepower. It's crazy fast for a full-size truck. We're going to just take it on a little off-road course around here, and then the real fun starts when we jump in the Gladiator and see the next generation of product. Well, we are starting it off right, just doing a quick ride in the Magna EtelligentForce. We've done this vehicle before, an 83 kilowatt hour prototype battery pack. What we have going on here is a dual permanent magnet setup. There's a front electronic disconnect on for the front permanent magnet motor, so you don't have flex related losses. We have an off-board inverter in the rear on this particular one, but now they're also doing inverters mounted directly to that motor, which, you know, it's an unsprung component of the vehicle. It's going to get shaken to death, but they now have new tech where the inverter can handle the abuse loads that this thing is going to see, which is really cool. And we're going to be driving that again in the Jeep. So consider this really the, you know, showcase, the initial showcase. The Jeep, a lot of Gen 2 technology, a lot of more refinements coming to that vehicle. So let's just go back in the EtelligentForce here, talk about driveline controls. There's been some new tuning done for this as well, which I'm looking forward to trying out. And then we'll jump in the Gladiator and go for another rip. You mind if I kind of set this up
Sure.
a certain way?
Yep.
All right, so we'll just go creep off and everything else. So this is your low range thing you were talking about.
Correct.
So we'll lock the rear axle when we get into something spicy out there. And then this regen strength, you have 7 settings of regen.
It's just a portion of how much energy you're going to burn with the brakes versus going back into cogen.
Of course. Yeah. Great. Well, let's go try it out.
Okay.
Great. And we're just in all-wheel drive mode right now.
Correct.
Which locks the front axle on. But then there's also new logic for an automatic reconnection strategy.
Correct. That would be the auto mode. Yep, we're going to go up the hill. That would be the auto mode. That's for efficiency improvements.
Right. So that would keep. So you have reduced flex related losses when the connector when you're disconnected, basically. But then the reconnect strategy would happen under hard acceleration or under a vehicle yaw movement, perhaps. Or even if you have wheel slippage in the rear, it would, you know, reconnect quickly to pull you to the front.
Correct.
Okay. And this vehicle is capable of doing all of those.
Yes.
That's very cool. It's amazing how quiet this thing has stayed as well from, you know, a rattle and twist perspective. Mm-hmm. This truck's been through hell and back, and it's still pretty amazing.
This is still a 3/4 ton truck.
Exactly.
So it's
got a toe.
It's leaves in the backs and torsion bars in the front. So.
Right. And you're using just factory suspension, right?
Yes. Yeah. Yes, exactly. This is a direct bolt-in for what was in here.
Right, and it's kind of cool. I mean, I'm sure you've been on some of these, but when you show other automakers, you know, obviously you're pitching your components to them. They must just be blown away when they drive this, of just how well integrated everything is and all of that. It's really...
Yes, we've received, I won't say nothing but positive feedback, but yeah, we get a lot of compliments about how well this vehicle and the Etelligent train.
So I'm just going to stop here for a second. I want to try this really quick.
Okay.
And it's a simple like that. And do you mind if I up the regen a little bit?
Certainly.
So let's just go max regen, low range. And so, yeah, you can already feel it. And that's just motor control holding us back.
All motor control.
And that's really fascinating. So we can back down the regen to maybe if we're, yeah, so there's 0. But even then, it's still holding us back. Mm-hmm. And this is simulating, you know, if you're low range, first gear, engine torque, or the drag of it basically holding you down. We're creeping along at a half a mile an hour. And I can feel a little pulses of regen versus not there, but still just, we're also going up and down over obstacles. Mm-hmm. It's pretty fascinating. If we go back to high, it'll basically unlock and let us rip. So that is a really cool function right there. Well, like if you drive a Tesla at low speed or Rivian at low speed and you let off the throttle completely, you know, it'll essentially, they'll regen you to a stop. Mm-hmm. But that last, you know, half a mile an hour to 2 miles an hour, it blends in the friction brakes to hold the car.
Yes.
And so in a situation like this, you'd actually be riding the friction brakes electronically, lifting off the accelerator pedal.
Yes, correct. This won't bring you to a full stop.
No, because it's all just in motor control. Yes. Which is, that's the cool part about this. Well, you join us now inside the EtelligentForce. We're back in here because I want to demonstrate a really important technology to electric vehicles that we're going to see in more production quality, production level vehicles. And it's an e-axle disconnect, essentially a way to disconnect the front motor, typically a permanent magnet motor, where you want to reduce the flux related losses of having the motor spin around. You can save, you know, relative, maybe a few kilowatts of drag by basically opening up a clutch up there. And, you know, but then the question becomes, how do you re-engage that front motor? And what you don't want to do is have to come to a stop and then close a connection there. You want to be able to, on the fly, basically have, you know, let's say in this case, primary axle rear drive, and then blend in front when you go hard throttle, very similar to how we've seen GMP, Hyundai, Kia, Genesis do it with their vehicles. What's your impression of a disconnect function, and how is it implemented here?
So in this vehicle, it's implemented with a couple different options. We can either select manually between all-wheel drive and rear-wheel drive, and we can also use this auto feature. And the auto feature is designed to automatically disconnect the drive when you don't need it in terms of total vehicle power or to support vehicle dynamics. And then if you get into the pedal or we detect a situation where you need all-wheel drive to stay stable, then it'll automatically spin up that front motor and connect the FAD immediately.
Yep, so you just basically rev match, slam them together, and you're good to go. And what's the, obviously there will be different time ranges of reconnect, I imagine. If you're going for a low NVH, you can take a little bit longer if there's not a lot request, as an example. Or if you have, you know, yaw on the vehicle, you're in an emergency situation, you want to get that slapped together. What's the strategy there?
So the strategy is, as soon as we detect that you need it, we'll start spinning up the front electric motor and then connect the dog clutch disconnect as fast as possible. So for the situations that we look at in the vehicle, we can do that in 250 milliseconds or less.
Wow.
From start to finish.
So 250 is worst case scenario.
Worst case scenario.
Wow. All right, great. Well, let's try it out. We'll just get a little bit of movement on. We're in rear wheel drive right now. I know that because I just spun the rear axle. I'll keep consistent pedal pressure, and we've hit all wheel drive, and we'll come in on brakes. Genuinely didn't feel that at all. Can we go out this way, do you know?
Yeah, we can just go down like the main road.
I want to try that again. That was fascinating. And I like that you call it a FAD, a front axle disconnect.
Yeah, for front axle drive, front axle disconnect.
Okay, front axle drive.
What do you usually call it?
The clutch disconnect.
Clutch disconnect.
Yeah. But there's been no real like industry agreeing term on that.
We just say FAD.
Yes, FAD. Okay, cool. But that only makes sense if the rear is your primary axle.
True. Yep.
We're good to keep going straight here?
Yeah, let's just go out to that main road where we were doing the launches.
Oh, sure. Okay.
It's probably the biggest long road we have.
Great. So we'll take a pause and we'll see you over there. All right. So just to kind of recreate that situation, we're on a bit of a bumpy road, but there's a little bit of a flat area here. I'm going to go constant throttle. We're going to hit all-wheel drive. It just connected. There was no noise. There was seemingly no clunk or anything that happened. That was pretty fascinating. Better than any production quality disconnect, reconnect I've felt. Just want to go back to rear wheel. So now it's just transferred there. And I mean, definitely just rear wheel because we're spinning it up there. Pretty freaking awesome. So now what I'm really curious about is this auto mode. So the auto mode will go and connect the front axle pretty much for 3 different scenarios. An emergency slide where you want to have available power and ESP is kicking in, when you give a hard throttle request, or when there's slip. Power steering pump?
Yep. It also auto connects at low speed like this to prepare you for the launch.
Oh, interesting. Okay, so at low speed, at least the way you've tuned this one.
We've tuned it, yep.
Yep. So, and how will we know what mode it's in? Will it highlight?
Yeah, that's what's highlighted here. So right now it's telling you it's in all-wheel drive. If we accelerate slowly, it should eventually disconnect to rear-wheel drive.
Yeah, let's try that out. So we'll just go very gentle throttle application, get some vehicle speed on.
One thing just remembered is that I think we may have put a surface mute condition on this. It may not disconnect unless we're on asphalt.
Flat.
Yeah.
Okay, interesting. So maybe we won't be able to try the auto mode, at least on the dirt. But we'll go to rear wheel drive. I mean, that's just, you know, I can hear ESP back to all wheel drive. No difference in the way that it drives.
Yeah, the goal is really to make it imperceptible to the driver.
It is getting a little bit more running out here than it was earlier in the day. Anyway, that's just a little bit on front axle disconnects. Let's go see some more Magna tech. Anyway, let's just do one last try. But oh yeah, here we go. And the pump's kicking up.
The power steering pump
Yep.
really gets in when you start getting high throttle position.
Okay, so then we'll just put everything back to the way we had it for you. Sorry about that. I always got to do. It's sort of mandatory. Whenever we drive a Magna vehicle, we go sideways somewhere.
Okay.
Well, you join me inside of the showcase tent with my friend Mike from Magna. How's it going, Mike?
Good. How are you, Carl?
Doing well. So we're about to go out for a drive in the Jeep Gladiator that you've converted with your new powertrain technology. Can you walk us through a little bit on how that vehicle's set up and some of the key learnings that you have here in the materials you're showing us?
Yeah, sure. So what you see here are the drives that have actually been in that vehicle and removed, so we can show you.
Right, I can see it got some dirt in here and stuff. Nice.
So this is the rear eBeam out of the Gladiator that we're demonstrating today. You can see it has coil suspension, whereas the truck that we showed you had leaf suspension.
Yep.
The other big change here is that we've integrated the inverter onto the eBeam, which is quite an engineering feat to make sure that it can deal with all the shock and vibration on this unsprung mass. So that's a great step forward that makes it more efficient, longer range, of course.
And also, I just want to touch on this. This is a huge deal.
Yes, it really is. And we've managed to shrink the size of the inverter by 30% as well. So continuing to develop and make better, more efficient, which equals longer range. But to be able to withstand the shock and vibration of these vehicles, especially when they're driving fast off-road, is huge. And this is what you'll drive today. So this is exactly the setup in that Gladiator.
Okay, so we have a coaxially mounted electric motor in the back.
Correct.
We have a 14-to-1.
The rear is about 12-to-1.
12-to-1.
The front is about 14-to-1. So 238 kilowatts peak. And this axle can provide 7,500 Newton meters of peak torque.
At the output shaft.
Correct. Yep.
Now, can you tell us, our audience, and I really hope we can do some more videos together, you and I, because you are really a genius when it comes to electric motor design. You've been doing it for years, 20 years, something like that.
Over 20 years.
So can you explain to our audience, I know there's some new motor technologies coming that we were discussing. You've been involved with axial flux for a long time, very high-end, expensive motors. Why would a permanent magnet motor such as this work in this application?
Yeah, the key words really are torque density and power density. So you could achieve this performance with an induction motor, but it would be much larger and the efficiency would not be as good. So to get high efficiency, lots of power and lots of torque, the only really affordable technology today is permanent magnet. We'll be looking at other motors that can reduce our reliance on rare earth magnets now and in the near future. But right now, the only affordable way to achieve this power and torque is with a permanent magnet motor.
And it's what we've seen Tesla doing, it's what we've seen others doing. It is the correct choice for a primary axle today.
It is today, but we do know from a sustainability point of view, we want to limit our reliance on these heavy rare earth materials, such as the magnets in these motors. So we have lots of developments underway to do that, but right now, permanent magnet is the only way to achieve this performance in this package size and be affordable.
So let's move over to the front axle then, because this is a very similar electric motor, but I've noticed it's no longer mounted in line or coaxially with the front axle. What's going on here, sir?
Yep, so this is a front steerable eBeam that we developed for the Gladiator. Slightly less power, it's about 180 kilowatts and about 5,500 Newton meters of torque.
Yeah, just 5,500.
Yeah, so it's very capable. It will give you exhilarating performance in the vehicle, but because of the additional steering components, we had to make the motor offset. So we couldn't have a coaxial design. There just isn't space in pretty much any vehicle to fit a coaxial motor in the front. So we moved the motor offset. We also have to put a disconnect in here because it's a secondary drive, as well as an electric lock-in differential and a park lock. So all of that in a very small package, as lightweight as we can get, and I think when you drive it, you'll really like it.
Also mentioned that you have an e-locker front and rear,
yes,
controlled inside the housing. Is that hard to do, or what's your impression on efficiency gains or losses?
It's real bread and butter for Magna. It's what we've been doing. Our off-road heritage goes back decades, so we've been working, and we are the global leader for four-wheel drive, all-wheel drive systems with our transfer cases, software as well. So for us to incorporate that kind of technology into this, it's what we do. It really is bread and butter to Magna.
Yeah, very cool. Well, thanks for showing us both of these. We pretty much have the identical drive units and e-beams inside the Jeep. So let's go for a drive. Let's talk motor calibration, throttle calibration, a few different drive modes, and we'll head out right now. Well, you guys join us in the Jeep Gladiator, which isn't really a Jeep Gladiator anymore. It's now completely powered with Magna's powertrain. And so, Jeff, what did you have to do to adapt this vehicle to electric?
So we've torn out all of the ICE components and replaced it with 2 eBeam axles front and rear, and then also put a battery pack in the center. So basically as much battery as we can fit between the frame. And then we replaced all of the stock vehicle controls with Magna controls for vehicle, inverter, and then traction as well.
Yeah, let's go for a drive. Everything operates as normally in this vehicle.
Yep, that's correct.
Into drive.
The only difference there is on the far left, instead of a tachometer, you have a power region. Besides that, everything pretty much works like the OEM vehicle.
So this will be, 400 kilowatts in a sense. So it's okay. That's pretty cool.
And you see the same thing on the center screen. So this is Newton meters of regen torque and kilowatts of drive power.
That's a very interesting scale that you have there. And I just want to check to see all of our settings here really quick as well. So we'll do regen creep off.
Yep.
So sorry, I don't know why I said regen, but creep off. Regen strength, what's your recommendation for this course?
So for this, I've been having people drive just around with normal regen, but if you feel like you want to try it out, I'd say feel free. We'll also show you our Etelligent low range mode, which is sort of a one pedal mode for off-roading.
Yeah, definitely want to talk about adapting electric for a little bit of off-road situation. Also here, just like even inching it along, there's no cogging.
Yeah.
It's so cool. That's awesome. No major NVH at low speed or that boominess that you get. It's just awesome. So we'll just kind of walk it down here then.
Yep, for sure.
And tell me a little bit about that simulated low range mode that you were talking about, because there's no physical transfer on a gear situation. It's a fixed gear ratio.
Yeah, that's correct. So it's a fixed gear ratio front and rear, but when we look at an ICE vehicle, we see that the biggest thing that you might shift to low range for on surfaces like this is to get more controllability of the vehicle. Okay. So basically that means you have more torque available at lower speed. So what our Etelligent low range feature does is try to mimic that with electric only controls. So when we turn it on, you'll feel that the vehicle creeps a lot slower, and then you also have a lot more torque available at that really low speed.
And that's just all software controlled.
It's all software controlled. Yep.
That is really awesome. Hey guys, well, we're taking a pretty hard path up Mount Magna here at Hollyoaks Off-Road Park, and we're going to do 2 different settings, and this is really why we're in this vehicle. The first is we're going to drive in the standard, I would almost call it street pedal mapping mode, which is still obviously off-road adapted for an application like this. Really huge torque at low speed. So I'm just walking it up in sort of street pedal mapping. I'm having to be really conscious of my foot movement on the pedal, have it kind of jammed up into the firewall, if you will, or at least the center portion of the vehicle. And I mean, the just impressive as to how slow I can go and how much power I have pretty much at 0, which I know I imagine most journalists will say, like, that's really cool of electric. I've also been able to do this with a lot of different electric vehicles. It's a next step up from what I've experienced so far in those vehicles. So now we're going to try the sort of off-road pedal map. You call it like a low gear, if you will.
We call it our Etelligent low range, but yeah, it's essentially an off-road mode that allows you to have sort of lower speed control that makes it easier for less experienced off-road drivers to go up features like this.
Okay, so how do we do that?
So we'll enable it actually with the start-stop button in this vehicle.
Oh, interesting. How about that? And
so you can see on the dash now it says off-road. You're in this off-road mode. When you let off the pedal, you'll feel it creep a little bit slower.
Oh, I'll add creep off. There we go.
Right.
I just wanted to go forward. So it just has a lower target speed for creep.
Yeah,
which is
target speed for
about a half a mile an hour.
2 kph.
2 kph, okay, so close to 1 mile an hour. Cool. And yeah, so we'll go creep on. And do you target creep up to regardless of power output to reach that speed?
Yeah, so we'll look at the sensors to try to figure out what kind of grade we're on, or we're compensate for that to keep you going at the same speed up different grades.
So we may not even need to hit the throttle.
Yeah, if you don't hit any slip, you should be able to get up there without any pedal application.
Oh, that could be interesting. I do want to try the pedal application though, because that's cool. I'll try and take the same line that we did coming up, which is roughly this one here. So a little slip, we'll just kind of power through it, all good. We don't have anything locked right now, so we're full open diff, and I can definitely modulate the throttle quite a bit more really nicely tuned for an off-road situation. And what's cool is, I just want to come to a stop here really quick. We have the rear in a divot. The front's quite high. The camera never shows this that well. And if I just come off the brakes, creep is going to just instantly pick us up. So we have no rollback, and it holds us at a really, you know, low speed. I mean, there's some, I guess, technologies out there that will have you like an off-road cruise control, if you will. Toyota has it, Land Rover has it, of course. But this is so much more user controllable than just relying on an electronic system. It's sort of an aid to get you up the hills. And the throttle is pretty great. And then, of course, we get huge regen in this mode. And we can see our regen torque here. And what's cool about this is, like we saw in the EtelligentForce truck, we're doing no friction brake blending at all.
Yep.
This is all in motor. Super nicely tuned in this one. Actually better than the EtelligentForce.
Yeah.
EtelligentForce was slightly surgy. This is next level. Just the silent nature, the no boominess or cogginess, as we would say, is really amazing. That finite granularity of throttle pedal, you know, movement relative to vehicle output is just amazing.
The idea is to give the driver as much control as possible and then make it as easy as possible for people who maybe don't have as much experience off-road.
And again, this is just a technology demonstration. When an OE purchases this, they can go crazy, or they can do whatever they want in integrating this into their vehicle. So what a cool system. Thanks so much for showing us this.
Yeah, for sure.
All right, so we have traction control off, all-wheel drive mode selected. What are our power outputs on this particular one?
Up to 440 total kilowatts of the vehicle, so about 220 front and rear.
Okay, very cool. So pretty evenly spec'd.
Pretty evenly spec'd. Yep.
So let's do a wide open throttle launch, shall we?
Let's do it.
Let's do it. Just instant to the moon. They sound really cool. The little that's awesome. Yeah, now we're talking. That's freaking cool. So cool to see Magna's in-house drivetrain expertise, motor control, and software strategies that can take electric off-roading to the next level. Join me in the next video where we'll head to Troy, Michigan, and look at several more technologies in Magna's headquarters.